Hello, everyone. I hope your studying for your final is going well. Um, but today, I wanted to focus a little bit on some word problems involving systems of linear equations. Now, while I do think it is worthwhile studying systems of linear equations for the final, I probably wouldn't worry too much about word problems. In past exams, there have not been that I can recall, at least in recent exams, there have not been word problems involving systems of linear equations, or really that many word problems at all. So if you're stressing out about word problems, I probably wouldn't. This again, that's no guarantee. It doesn't mean you shouldn't know what to do here, but if you're trying to narrow down what to study, I would probably focus more on the algebra side of it and less on the word problem side of it. However, it is probably important to know what to do, at least for the homework. So let's go ahead and do a few of these word problems involving systems of linear equations. Um, Now, the thing I want you to focus on as we do a few of these word problems is just some of the basic techniques that we're going to use to solve some of these word problems, not necessarily the specifics of them. Okay, so if you see some theme in here, just know that you can apply this to other problems. Okay, so let's go ahead and dive in. So this first one here, it says we have a fruit company delivers fruit in two types of boxes, large and small. And it says that two large boxes and three small boxes have a total weight of 50 kilograms, and four large boxes and eight small boxes have a combined weight of 113 kilograms. How much does each type of box weigh? Okay, so we are maybe not so directly given a system of linear equations here, just in the way this problem is worded. So, before we can create a system, though, we have to decide on our variables. So I'm going to say L is our large boxes. And we're going to, just because sometimes my S's look like fives, we're going to say A is our small boxes. Okay? So those are our two variables here. So what we have here, just looking at this, we have two large boxes and three small boxes have a total weight of 50 kilograms. Okay, so if we have two large boxes, so 2L plus 3A, that's going to be equal to 50. Okay, and it also says we have four large boxes and eight small boxes have a total weight of 113. So we also have that 4L plus 8a is equal to 113. Okay, so since we know that the weight of the large boxes and the weight of the small boxes are constant, or they're fixed, we can treat this as a system of linear equations. Okay, they're not different weights for each individual box in each of these equations. They're connected together in one system, so we can treat them as a system of linear equations. So now we can solve this just like we would any other system of linear equations. So my first thought would be to take this top equation here and multiply it by -2 so that we can eliminate the L variable. So let's multiply this top one by -2. And this is going to give us -4L minus 6A is equal to -100. Okay, because we're multiplying everything in this equation by -2. And we're going to leave the bottom equation alone. So we have 4L plus 8A is equal to 113. And now what we're going to do is we're going to add these two equations together. So we have -4L plus 4L. These will cancel out, so we get 0. And then we have -6A plus 8A gives us 2A. And then we have -100 plus 113 will give us +13. So now we can just divide both sides of this equation by 2. Again, we can just sort of pretend that 0 isn't there, right? Because we got rid of that. So we have 2A equals 13. So we can divide both sides by 2. And we get that A is equal to 13 over 2. Or we can just think of this as 6.5. Okay. So now Let's go ahead and see if we can solve um, for the L variable by plugging this A value back into one of our equations. So I like the top equation better. So we're going to take this A and we're going to stick it right here, okay? So we have 2L plus 3 times 6.5 should be equal to 50, okay? Not too bad. So we can do this in our heads, or we can use a calculator. Either way is fine. But we'll have 2L plus 3 times 6.5, which is 19.5. So we get 2L plus 19.5 is equal to 50. We can take 19.5 away from both sides, and we'll get that 2L is equal to 30.5. Okay, now we can divide both sides by 2. And we get that L is equal to 30.5 over 2, or if we wanted to find out exactly what this is, we can come up with 15.25. So the small box will weigh 6.5 kilograms, and the large box is going to weigh 15.25. Now, one thing to remember when doing any of these word problems, especially with word problems, this is always true, okay? The thing you want to ask yourself is, does your answer make sense? You would be amazed at the number of times I get back on a test where I include a word problem like this, or I see someone trying to work through a word problem, and they come up with something like where the small box will weigh more than the large box, and that doesn't make any sense, right? The small box should weigh less than the large box. So if you get an answer like that, that's a really, really good indication that you should go back and check your work and make sure that you didn't make a mistake somewhere. So you should always be checking yourself in these word problems. Does this make sense? This is really just a skill you should try and develop in math in general, not just in word problems. You should always be asking yourself, does this make sense what I'm saying here? Does my answer make sense given the circumstances? Okay, so we're going to try to apply that as we continue here. So the next problem says we have a party rental company rents chairs and tables. And it says the total cost to rent 2 chairs and 12 tables is $107. Speaking of making sense, I don't know who would rent 2 chairs and 12 tables, but it works, okay? It's an example, whatever. So then it says the total cost to rent 5 chairs and 3 tables is $38. Okay, so what is the cost of each chair and table? So one thing you should probably think to yourself here, if just think about a practical situation. If you were going to a party rental company and you're renting chairs and tables, which one do you think would probably cost more? My guess is the table would probably cost more than the chair. I get unless you have some really fancy chairs. I think in most situations, your tables are going to cost more than the chairs. So that's something to think about as you're solving this problem. You should probably get back that the tables cost more money. Okay, another way to look at that would be maybe to think, okay, well, the total cost for 12 tables and 2 chairs is $107, and the total cost for 5 chairs and 3 tables is $38. So when you have more chairs than tables, you get kind of a smaller number, you get more tables and chairs, you get a much larger number. That's not necessarily a guarantee that that's how it's going to play out, but that could be another way to maybe give yourself a sanity check as you are going through the problem. Okay, so let's look at our system of linear equations we have here. So we have 2 chairs and 12 tables is $107. So let's say that our chairs we're going to represent by C, and our tables are going to be T. Okay, so we have our first one. We have 2 chairs and 12 tables add up to $107. So we have 2C plus 12T is equal to 107. And then we also have that 5 chairs and 3 tables add up to $38. So we have 5C plus, plus 3T is equal to 38. Okay, So now we can go about trying to solve this system of linear equations. So my bet would be it's probably easiest to eliminate this t variable. And my thought here is all you have to do is multiply the bottom equation by -4, and you'll get a -12t in that equation. And then you can eliminate the t variable quite easily. So let's do that. So we can multiply the bottom equation by -4, and then that's going to give us, on top, everything will stay the same. So 2c plus 12t is equal to 107. That's fine. And then now we have 5c times -4. That's going to give us -20c. Okay. And then we'll have minus 12t. And then 38 times -4. Confess I don't know off the top of my head. That is going to be a -152. Okay, cool. So let's go ahead and add these equations together. So 2c plus a -20c, or 2c minus 20c, is going to give us -18c. And it looks like these 12s, or the 12t's are going to 12t and -12t. That'll disappear then. And now we have 107 plus -152. And that's going to give us -45. Okay, so we can go ahead and divide both sides of our equation by -18. And we'll end up with c being equal to -45 divided by -18. And that's going to give you 2.5. So we know that a chair is going to cost $2.5. Another thing too to remember here is, since we're dealing with negative signs like this is a good time to talk about this. If you're talking about a price of something, you should never get back a negative number. So let's say you would have forgotten one of these negative signs and you would have ended up with the chair costing -$2.50. They're not going to give you $2.50 to take the chair. You're going to have to give them $2.50 to take the chair. So again, just make sure that your answer makes sense given the situation. Okay, so a chair is going to cost $2.50. So now we can take this 2.5 and plug it into our favorite equation. And I'm thinking, let's do the first equation. So we can plug that in. So 2 times 2.5 plus 12t is equal to 107. Okay, so 2 times 2.5, that's 5. So we have 5 plus 12t is equal to 107. We can take 5 away from both sides, and now we end up with 12t is equal to 102. And then now we can divide both sides by 12. And we get that t is equal to 102 divided by 12, or 8.5. So we know that a chair will cost $2.50, it's $2.5, and a table is going to cost $8.50. Okay, another sanity check here. They're both positive, so everything looks good there. And the table costs more than the chair, just like we expected it to. So this is an answer that makes sense. Okay. So yeah, that's something you should always, again, not to repeat myself, you should always be checking that your answers actually make sense given the real world situation. Okay, let's look at a slightly different type of word problem here. Okay, here we have an airplane controller is tracking two planes. To start, plane A is at an altitude of 1,551 feet, and plane B is just taking off. Plane A is climbing at 35.5 feet per second, and plane B is climbing at 70.75 feet per second. How many seconds will pass before the planes are at the same altitude? I want to know what their altitude will be when they are at the same altitude. Okay, so let's see if we can come up with an equation for each of these, and then maybe we can try and relate these two equations in a way that will help us solve this problem. So we have that plane A So we have, we'll just say that A, in this system here, A is going to be the altitude of plane A. Okay, and we're going to let B be the altitude of plane B. Okay, so that means we can use A as part of our equation. So plane A is climbing at 35.5 feet per second, and it started at 1,551 feet per second. So here, I actually want to let since we want to find out how many seconds, since we don't know the seconds, since we want to find out how many seconds before the planes are at the same altitude. That's an unknown. Okay, so let's go ahead and say that x is seconds. Okay, and we know that plane A is traveling at 35.5 feet per second. So for each second, we're traveling 35.5 feet. So we can say that A, the altitude of plane A, is equal to 35.5 times x. Okay? I mean, and you can kind of check if this makes sense along the way. So at 1 second, if x equals 1, we'll be 35.5 feet higher than where we started. And then at 2 will be 2 times 35.5 feet per second. So you kind of get the idea. It's climbing at a constant rate, and x is our seconds. But we also have that it starts at an altitude of 1,551 feet. So let's go ahead and add 1,551 feet. Okay, so this is our equation for the altitude of plane A. All right, and it says that plane B is climbing at 70.75 feet per second. Okay, and it also said that plane B is just taking off. So we can express the altitude for plane B in a very similar way at 70.75 times x, again, where x is seconds, plus 0, because it started at the ground. It's just taking off. Okay, and now we want to find out how many seconds will pass before the planes are at the same altitude. Okay, so what we can do in order to solve this is we can we can go ahead and set these two equations equal to each other. Okay, so because again we know that we say that A is equal to B. We're looking to find out when the altitude of A is equal to the altitude of B, where we said A is the altitude of plane A and B is the altitude of plane B. So we can set A equal to B, which this would imply that 35.5x plus 1,551 is equal to 70.75x plus 0, or we can just leave that part off. And now what we're going to want to do is solve for x, because it says how many seconds will pass before the planes are at the same altitude. So to do that, we can go ahead and subtract 35.5x from both sides, and we'll get that 1,551 is equal to 70.75 minus 35.5. We get 35.25x, 35.25x. Probably didn't need a calculator for that, but that's all right. And now we can divide both sides by 35.25. Okay, these will cancel, and we get x is equal to 1,551 divided by 35.25. And we get x is equal to 44 seconds. Okay? So after 44 seconds, these two planes will be equal to each other in altitude. And again, another thing to check is make sure that this makes sense. Okay? So it's not, millions of seconds, right? If you get some crazy huge number, that might not make sense. It might make sense given the problem, but probably not for this one. Um, because the second plane is taking off, it's traveling quite a bit faster upwards compared to the other plane. But there was an advantage for the first plane. So we expect that it takes a moderate amount of time to get there, but not too long. And then we also know that it's an amount of time, and you can't really have a negative amount of time, so it's positive. So that's good. So it says that we have 44 seconds, and we can probably accept that as our answer. Okay. Now, if we want to find out the second part of this, it says what will their altitude be, and that's implied that when they're at the same altitude, what will their altitude be? We can plug in 44 seconds for either of our equations here. I'm going to choose B because there's nothing we have to add to it. And since A and B are equal to each other, that's why we get to choose either one. So we can say that B is equal to 70.75 times 44. Okay, and that will give us 3,113. Okay, so it will be 44 seconds and 3,113 feet. And again, another sanity check here. You should check that this makes sense. Again, if you got back some negative number, again, that would probably not make any sense here. They wouldn't be underneath the Earth. They would be in the sky, right? They're at a positive altitude. That makes sense. And it's also a higher altitude than what they both started at. Plane B started at 0, and Plane A started at 1,551 feet. So we would expect that after they both climbed for a little while, they would both be at a higher altitude than when they started. So you should always be checking in these word problems, does this make sense? Is what I'm doing, is my answer compatible with the real world situation here? That's probably the best piece of advice I can give you for solving these, is always be doing sanity checks along the way. But as always, if you have any questions at all, please feel free to email me and let me know, and I would be happy to help you, or even make another video with a few more examples like this, if you wish to see that. But good luck, and have a good one.